Okay, this video is designed to highlight another use for tangent lines. Up to this point, we've used tangent lines to find the slope of a curve at a given point. And while that is certainly useful, tangent lines have another use, and that is to approximate the value of the curve at points that are close to the point that the tangent line and the curve have in common. So here is a problem that highlights this use. We'll start by reading the problem here. Find the tangent line approximation, capital T, of the function f of x equals 1 plus sine of x at the point 0, 1. Then complete the table below to compare the y values of capital T, our tangent line, with those of the function f of x. So if I were to reword the problem and just ask to find the tangent line to the function at that point, the two things that we need to write the equation of a tangent line are a point, which is given to us, 0, 1, and the slope of the function at that point. Of course, to do this, we need to find the derivative of the function and then plug the x value of our point, which happens to be 0, into the derivative so that we can get the slope of the function at that point. And then we use point-slope form to write the equation of the tangent line to that curve at the point 0, 1. So thinking about what f prime of x would be, the derivative of 1 is 0, and the derivative of sine of x is cosine of x. So f prime of x is simply cosine of x. And if we plug 0 into that derivative, so f prime of 0, the derivative of the function at 0 would just be f prime of 0 equals the value of the cosine of 0. Of course, drawing back on the unit circle, at 0 radians, the cosine value is 1. Therefore, if we were trying to write the equation of a tangent line to this curve at the point 0, 1, we would use the point 0, 1 and the slope of 1. Putting that into point-slope form and doing a little bit of algebra work to put the equation in slope-intercept form, we would come up with the following. So you can see f of 0 equals 1 is our point. F prime of x equals cosine of x is the derivative of the function 1 plus sine of x. If we find the slope of the function at 0 by plugging 0 into the derivative, cosine of 0 is 1. Here is our point slope form, so y minus 1 equals 1 times quantity x minus 0. Distribute the 1 and then add the 1 over to get the tangent line y equals x plus 1, which we're going to call capital T equals x plus 1. So again, the function f of x equals 1 plus the sine of x has a slope of 1 at the point 0, 1. You can see over to the right here, there is kind of just a sketch of what this would look like, but the function f of x curves through the point 0, 1, and the tangent line also goes through that point with the same slope as the function at that point, which has a slope of 1. So we're going to take this a step further now, and we're going to use that tangent line to approximate values of the function that are close to the point that they have in common, which is 0, 1. The key to this whole process is recognizing that tangent lines can be used to approximate values of the function, but only if we are approximating values that are close to the point they have in common, which in this case is 0, 1. If we move further away from that point, for example, if we're further to the right or further to the left, you can see that the curve and the tangent line break apart from each other. And because of that, the tangent line doesn't give very good approximations after a while. So the values for the chart are already labeled here, so those are the answers that we're going to be looking at. And a really easy way to fill out this chart using your calculator is to use the table feature. So if we were to go into our calculator here, and we go to y equals, let's type in our function first, so 1 plus sine of x. And then let's type in our tangent line, y2 equals the cosine of x. And if we were to just hit graph right now in the standard window, you can see 1 plus sine of x cruising through there. So it's a sine graph that's shifted up 1. And I'm not really sure why I just graphed the derivative, to be honest. So let's actually go in there. Got a little sidetracked. We want our tangent line here. So our tangent line is x plus 1. My apologies there. So here comes our function cruising through again. And here's our tangent line. And as you can see, our tangent line and the curve both go through the point 0, 1. So we're going to use the red tangent line to approximate values of the blue function, but we can only approximate close. I mean, if we're way out here, even at, say, x equals 5, the tangent line and the function are way apart from each other. So the tangent line would not give us good approximations of the curve. If I were to go to my table right now, it's already preset to start at x equals 0 and go up by 1s. But if we take a look at what we're trying to approximate, we're only trying to approximate x values that are close to x equals 0. So negative 0.5, negative 0.1, so on and so forth. So if I go back into my table, a nice feature is we can hit second window, which allows us to change our table settings. And most convenient for this particular problem would be to switch our independent variable from auto to ask. And if we go back into our table, it appears as if the table got wiped clean, but what really happened is we can now put whatever x values we want in, and it's going to give us the outputs for both our y1, which is our function, and our y2, which is our tangent line. And if we pick values that are close to x equals 0, the tangent line value, y2, and the function value should be pretty close to each other. So for example, if we type in x equals 0, they should be the same because that's the point they have in common, and if we hit enter, sure enough they are. So if we wanted to fill out the rest of the table, negative 0.5, negative 0.1, negative 0.01, if you were to predict which x value would have outputs for the function and the tangent line that are closest to each other, whatever's closest to the point they have in common is going to give you the best approximations. So if we put negative 0.01 in, you can see that they appear to be exactly the same. Now, if we actually go to the numbers here and we scroll over them, you can see that this is actually an approximation 0.9900001, so on and so forth, and the tangent line is exactly 0.99. So they are very close to each other, but not exactly the same. If I were to ask you, does our tangent line give us a good approximation of the function at negative 0.01? Clearly the answer is yes. Now if we move a bit farther away, and we type in negative 0.1, you can see that they're already becoming a little farther apart. So the actual value of the function is 0.900166, so on and so forth, and the tangent line approximation is exactly 0.9. So once again, a good approximation, but they're starting to get further apart. If we go all the way to negative 0.5, now they're becoming even farther apart. So we still have a good approximation here, but the further you get away from the point they have in common, which is 0, 1, the less accurate of an approximation your tangent line is going to give you. You can do the same thing on the right side of the point, so if we put in 0.01, 0.1 and 0.5, you can see that as we get further away from the 0.01, our approximations become further apart from the actual value of the function. The values you see here in blue and red are the same values that are in the chart on the answer key here. Normally we round to 3 decimal places, but I went a little further just to highlight that as you get farther away, the tangent line doesn't give quite as good of an approximation as it does as you're closer to the point they have in common. Just to make a point here, if I were to type in something like x equals 5, like I had highlighted earlier in the video, you can see that the tangent line gives really kind of a terrible approximation. The actual value of the function is 0.04108. Of course, that's rounded, but the tangent line approximation is 6, so it's not even close. If you study more calculus beyond Calc 1, you'll discover there are ways to improve approximations, but at this point we are simply going to use tangent lines to approximate values of a function close to the point that the tangent line and the curve have in common. So in your homework you'll be practicing this to make the process easier. You're allowed to use a graphing calculator, and I would recommend that you use the table feature by turning the independent variable from auto task in the table settings, and that will allow you to fill out your charts quickly and easily, and you'll see exactly what was highlighted in the video.